So like I said for my last video, we will focus now on the derivatives, specifically on the four-step differentiation. Derivative of a function. So first we need to be familiarized with the symbol delta. Means change or increment. After that, let's jump into the process of differentiation. The first step is to apply the symbol delta to the parts of the function. Let's start with y. Let's make it delta y, and x to delta x, and we'll add it to the original y and x that doesn't have the symbol delta. And we'll have this y plus delta y is equal to f of x plus delta x. And now for the second step, we will isolate delta y by subtracting y on the both sides of the equation. And then we will have this expression delta y is equal to f of x plus delta x minus y. Then how did it become f of x in this final expression instead of y? That is simply because the function says that y is equal to f of x. So therefore, we can substitute f of x to y, and that's how we come up with this expression. So before you proceed to step 3, you need to make sure that there is no like terms or you already combine them. You will understand more later by my example. And now for the step 3, we will just divide it with delta x. Both sides of the equation will be divided by delta x. And now let's proceed to the final step, which is getting the limit of step 3, the whole set or the whole expression on step 3, which is delta y over delta x is equal to f of x plus delta x minus f of x over delta x. Let us first get the limit of delta y over delta x as delta x approaches 0. So take note that the limit of delta y and delta y over delta x is dy over dx, which is the derivative expression. And now we can use this final answer to the future problems regarding four-step differentiation process. Now let's use the four-step differentiation in this problem. Find the derivative of y is equal to x squared. So the first step is adding delta y to y and adding delta x to x. By doing so, we will have this expression y plus delta y is equal to x plus delta y squared. And then you will isolate delta y and substitute x squared to y. And as you can see, x plus delta x squared can be expanded using FOIL method. And the answer would be x squared plus 2x delta x plus delta x squared minus x squared. Look for like terms and combine them. As you can see, x squared and negative x squared are like terms, so it will cancel, leaving this term, and we can factor out delta x. Going to step 3, wherein you will divide both sides with delta x. This will cancel, leaving this term, and proceed to final step on getting the limit as delta x approaches 0. And we know that the limit of delta y over delta x as delta x approaches 0 is equal to dy over dx, and the limit of the other one is simply 2x by substituting 0 to delta x. And that's it.